Hey guys, this is Wojtek from Jolly Monster Studio, and today we're going to take a look at how to add some custom network calls to our games. Specifically, we're going to look at how to integrate with an API that returns a list of users and have our character here interact with an actor within the world that then retrieves that list of users, parses them, and displays them in a widget for us to interact and use within our game. So if I just pop in here, you can see we're doing a connection out to our API, and then we bring back some user details. This can be used for, registration, newsletters, any form of network data that you want to have stored somewhere out on the server within your game infrastructure, and have the games reach out and pull down sort of dynamically. So let's get started. Okay, so the first thing we're going to take a look at before we get too far into our Unreal development is the actual server, the API that is going to provide us this list of users. So I've gone ahead and created this little Java Spring Boot project. And why Java? This could have been done in any language, Python, Node, whatever you like for your web REST-based APIs. I just went with Spring Boot simply because I know it well and it was easy to spin up. And I think it's pretty easy enough to understand for anyone coming into this stuff kind of fresh. But let me show you what this thing does. So we have a couple of things going on. We're going to create a database table using an in-memory H2 data storage system. So that just gives us the ability to simulate a proper database. And what I have here is just a users table with a ID, a username, and an email that we're going to fill out. So the data component is where I'm inserting the users, and you can add or subtract as many of these entries as you want. Again, all this is going to do is on application startup, when our API comes alive, it's going to insert these records and make them available to our web-based calls. Excuse me. Looking at the user repository, that's the thing that's going to communicate with the database. It's using a simple JPA style retrieval of the records. And we have find all and find by username. So these are the only two sort of lookups we're going to be managing so far. And we're using this user entity as the thing to tie it back to our users table. So you can see I have a couple of annotations here. This is going to come back as a JSON object when we're retrieving it from our API under the title user. We also have the annotation of entity and the table, which binds it to the JPA repositories and lets us fill in automatically the properties when it's getting the data out from the database. Okay, so enough about sort of the reading and writing of the data. Let's look at our controllers and what they're actually up to. So they're pretty simple. We have a /users and a /user with a parameter of username calls, and they're both two GET calls. So we're not submitting any data to the server. We're just saying, hey, let's retrieve whatever this URL of users and username or parameter is serving up. And in here, all I'm doing is for users, I'm saying, hey, get me all the users out of the database. And on username, I'm looking for a specific user. And if I don't find that, or I don't find any users, I return a status code of not found, which is 404. That lets our application know that nothing is available for processing under these requests. And then lastly, I'm just introducing a sleep operation so we can slow down the request, because you'll see later on that it's pretty fast to get this information out of the system. And then we're also logging the information coming into the API so we can sort of evaluate how our headers from the Unreal communication or our web browser communication look and see if we need to adjust anything there. So hopefully this is not too confusing for anyone, but I just wanted to touch base on the API here as we're going to be growing it over time, so we can create users, modify them, add a bunch of these REST-based operations that any sort of website would use, but also your games could benefit from. And this gets into sort of the whole design of how you can have your web page, your mobile app, and your application sharing all kind of common APIs. That's all, longer down the tutorial chain. So let's first get started with examining our APIs. So I'm going to switch over to the browser and we'll play with them for a second before we go into Unreal. Okay, so in the browser, as you can see, I've included Swagger in our API. So it's a quasi-self-documenting library that monitors our controllers and then tries to annotate them sort of accordingly. So you can see we have our two methods here, get users and get user by username. And all this API Swagger documentation lets you do is give you notification about what these things are going to expect as input parameters, responses, error codes, things like that. But you can also execute the request to validate that your API is working correctly. So here I just ran it. We got a server code of 200 as our response and our 3 users back. If we flip back to our server-side code, I'll just show you the header definition, what that looks like. Okay, so looking back at our server, you can see, if I just zoom in here real quick, this was the request that we made. And it came from my Google Chrome browser. It had a refer of the Swagger page we came from and a bunch of other header parameters that we're going to need to worry about when we're implementing our Unreal game. Okay, let's go back to the Swagger documentation and just play with the other method call, make sure it's working correctly. Okay, so going back to Swagger, let's just double check that this method here with our parameter actually is doing something. So when we try to execute it, we have to populate the username. If we don't fill in the username, it's going to pitch an error. If we put in an incorrect username, it's going to fail and generate a 404 not found because we don't have that particular user. And then if we use something that we know exists, we get back our appropriate user with our email and our ID associated with it. Okay, cool. So our API works. All of the REST endpoints work accordingly. We kind of know what the data structures now look like. So we know how to parse these things within our Unreal code. And the only thing we have to worry about is, you'll notice the response structure for the many entries is wrapped in a user's parameter, while this one here, just by username, returns a raw representation of one of those single entries from this array. So just, again, something to keep in mind, because your pathing when you're parsing this content is going to be a little bit different. Okay, let's get into Unreal and start generating some of these actors. Okay, so now to some actual fun stuff within the Unreal editor. First thing we're going to have to do is create a couple of classes to represent our actor that does the networking and the widget that is going to be associated with it. So go into your C++ classes. We're going to create a new class. This is just going to be a straight up actor. We're going to put it in the network folder. And it's going to be our HTTP get actor. Okay, and our other class that we're going to create is a user widget that our actor is going to reference. So again, go and create a new class. Let's find user widget as our parent. And let's put this in the UI folder. And we're going to call this our HTTP response widget. Okay, so let's go ahead and jump back into the editor now that these two classes are created. Okay, so back in the editor, we're going to start with the response widget class and start fleshing it out a little bit. So it's going to be pretty straightforward. It's going to contain a vertical box that's going to be used for adding all of our messages, as well as our little loading icon that we're going to use the thrower component for within our widget. So let's go ahead and define the property for our vertical box. This can be added anywhere. Blueprint read write, and we want to set the meta tag to bind widget, and that's just going to enforce the requirement that this component is present on any user widget we create within our blueprint. And I'll show you what I mean by that when we actually get to the blueprint definition. So we're going to create a vertical box component, and always make sure to include the header file associated with that. Otherwise, you will have some issues. So it's going to be our user list box. And now let's add in a couple of methods that will allow us to add a user, clear the user box, and trigger the on-off state of our little loading icon. So I'm going to create a new function that's going to be blueprint callable, and that's going to be add user. And we're just going to pass in the username for now. We are going to expand on this later on, so no worries. I just want to get the one parameter flowing in for the time being. We're going to add another function called clear user list. And lastly, if I could spell function, we're going to create a show loading. So we're going to add another method to control the Boolean off and on state of our little loading icon. Okay, let's hop into the CPP of our header and start defining these methods. Okay, so for add user, what we want to do is create a text block. Text block. And make sure you include the header definition for that as well. Okay, so there's our text block. And somewhere lower down, we're going to say add child of text block to our user list box. So that's just going to boom, 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 insert new text records as we go along here. So now we want to set the text for this text block. So we can say, let's define what this thing is going to look like first of all. So let's create a new string. And this is going to be our text. And we are going to use the fstring printf function because we want to inject our parameters into our string in an easy way. So we're just going to say username, parameter s, username. Okay, and that takes in our string there. Great. So lastly, we want to say text block, set text from string, because it expects a different data type, and we pass in our text. Okay. So we have our username being added to the widget. We should now see some stuff happening as we debug further. Now in the clear user list, we're simply going to say user list box clear children, and that should clear out all of the content we were looking at previously. Then in here, we're going to say, if I'm loading, do something, otherwise do something else. And if I'm not loading, I'm actually just going to clear our list box so we can start fresh. And if I am loading, I'm going to create a circular throbber component. This guy here. And that's going to represent our little spinner that we saw at the beginning of the video. So we're going to call this our loading icon. I'm just going to create a new object of type circular throbber. Okay. Now, one thing you'll notice with this particular component is if you put in the vertical slot by default, it's going to be stretched out over the width of it. So one thing we want to do is we want to say, hey, change the orientation of it to be centered rather than filled by default. And to do that, you need to get the slot that you just inserted this item into your list and then modify its properties. So if we go down the logic path here, we would say user list box add child loading icon. And if we look at the definition of add child, you'll notice it returns a panel slot component or panel slot object. Panel slot. Now we can say if this was added correctly and we have a panel slot reference, we can convert it to a vertical panel slot or vertical box slot, which is tied to a vertical box, and then we can adjust that alignment I was mentioning. So vertical slot equals, we're going to cast. And there's our panel slot, and let's just double check that our vertical slot exists, and if it's all kosher, then we can say, set horizontal alignment to center. And you'll notice the other values are left, right, and fill is by default, which is why it's all sort of stretched out. Okay, so we got our slot, we modified its parameter, we handle the off and on state of loading. Let's compile, make sure everything runs, and then start fleshing out our actual actor that's going to retrieve these bits of network information. Okay, so going back to our HTTP GET actor, let's go ahead and define a couple of those attributes, or components rather, that we saw in the earlier video. So we're going to need an overlap component. So I'm just going to create a new property for a box component that is going to get triggered when the character steps into it and triggers our network event. So we're going to say meta allow private access equals true. And this is going to be a category of HTTP. So there's our box component. And it's our overlap component. Make sure you include all the headers for these components, otherwise the ID will give you some issues. Let's create another property, and this is going to be the widget component that our HTTP response widget is going to be using for display. So it's going to be a widget component, and we're going to call this our response widget. And let's go ahead and instantiate these components. So we're going to say overlap component, create default sub-object, pass in the type definition, and make sure you give it a name. Say overlap. We're going to set this guy to be our root component, and then our widget component. We also have to create and instantiate it. And we're going to call this response widget. And response widget is going to be attached to our overlap component. Okay. The other thing we need to do is define a method that is going to get triggered when our character actually overlaps with this component. So let's set up a little delegate call with on component begin overlap. Let's add a dynamic method, which is not yet available. We're going to create it just shortly. So let's call it on begin overlap. And you'll see it's complaining about this method signature because it doesn't exist yet. And we want to ensure that it aligns with the method signature being used by on component begin overlap. So the way you can do that quickly without looking at the documentation is control click on begin overlap, which takes you to the overlap signature, which you can control click into, and it gives you all of the parameters that go into it. So me being the lazy individual that I am, I just copy them, go back to my my header definition, and I create my new method here. So let's make it a function that is blueprint callable, and let's say void on begin overlap. Pass in these parameters we just copied, and you just got to make sure you get rid of these extra commas. Otherwise, the compiler will not be overly happy with you. Okay, there's our method signature. We go back to our actor. You see this guy's now happy. Let's define this method to make sure we have it available for later use. And I think that's, oh, actually, the other thing we're going to do, again, as you might have seen in the earlier video, the widget rotates towards the character. So we're going to put in a little bit of logic to make sure that happens. So if we have our response widget, so in the tick of our actor, the actor that's going to include our widget, we're going to get the player camera manager, and you can get that using the Kismet gameplay statics helper. Get player camera manager, pass in the world and the first player. Obviously, this would have to be a bit more involved if you have a multiplayer game, but for our little exercise, this is going to be just fine. So let's get our camera manager. And then we're going to use another little helper to get the lookout rotation. So rotation, and we're going to use the Kismet math library. And again, make sure you have all of these headers defined. So we are going to find lookout rotation. And if you're recognizing some of these calls, these are a lot of the blueprint immediately accessible functions that you'll see in a lot of blueprint tutorials. And rather than sort of defining your own, I mean, if you step into find lookout rotation, you can understand what the logic looks like. It's not overly complicated, but you know, it's already there. It's available to you. Why not use it? So this method takes in a start vector and a target vector. So the start vector is going to be our location of the camera of our player. So we can just say camera manager, get camera location, and our target's going to be the response widget component and its location. So get component location. Okay, and that's going to look or return the rotator of which we want to set the pitch to 0, the roll to 0, and we want to take the yaw and just rotate it by 180. And the reason being is by default, these components are just going to be looking away from the player. So we're just rotating around and then positioning it so it faces where the character is currently positioned. And lastly, we're just going to say response widget set set world rotation to be our lookout rotation. Okay, so whenever this component is now in the world, it should rotate accordingly. Let me recompile, and then let's go into the editor, or the visual editor, to make sure that everything is looking correctly. Okay, so back in the editor, let's double check that our item is working. Cool. There he is. It's rotating the way we expected. And we'll now work on our overlap for our actor to actually make the networking call. So let's go back to Visual Studio. Okay, so back in the editor, let's go ahead and modify our build CS file to now include the HTTP module. By default, you'll notice there's no reference to it, just a couple of default modules that the engine is referencing. So let's go ahead and add in these new ones. So I'm just going to throw these on a new line so they're a little bit more visible. So we're going to include the HTTP module, we're going to include the JSON module, and we're going to include the JSON utilities module. And then lastly, I'm also going to bring in UMG, and that is because later on we're going to do some additional UI work and some future tutorials. And we're also going to add a private dependency module name. And again, this is optional. I'm just putting it in here before I forget for some of our other upcoming bits of work. So we're going to add a private for Slate and Slate Core. And those are just extra modules for working with the UI components. Okay, but this is the big guy here, HTTP JSON. So I'm just going to recompile this, and now we can go back into our actor as this is going. So in our HTTP get actor, we need to get a reference to this HTTP component that's going to be doing a lot of this work. So if we now look for if HTTP module as our input parameter, we have it available to us through HTTP module.h, but we're just going to cover all of our bases and bring in HTTP h. That should just take care of the majority of these components. And why is that not recompiling correctly? No, there it goes. Yeah, here we go. It updated it. Sorry, just took a second. Okay, so we have our HTTP module, and this is the guy that's going to be doing the majority of the work. What we want to do is in our constructor is we want to catch a reference to that object. So we're going to say HTTP equals module get. Oh, sorry. HTTP module get. Okay, so we got a reference to the HTTP object, and now we can start doing some stuff with it. So in our onBegin overlap, if you recall, we weren't doing much. So now we can be a little bit more detailed in what's going to happen here. So the first thing we want to do is create the loading state for our circular throbber before we get the network request. The network request is going to generate callbacks, and then after we process the data from those callbacks is when we turn the loading throbber off. So let's go ahead and grab a reference to our response widget. And that's going to be our response widget. And we're going to get this from widget, get widget. Sorry, let's do this first. If response widget, because we want to make sure this thing is actually available to us. And I'm a dummy because we're using the same names. Let's make this a response widget component rather than response widget. Okay, so I just very quickly renamed that response widget component. There we go. Get widget. So we get a reference to the widget we set for that component. We cast it to the thing we want. We do another if check just to be on the safe side because we're paranoid. Response widget. And now we have access to our method signatures. So we want to trigger loading to go. And if that is all cool, then lastly, we're going to send our and we don't have this method yet, this send HTTP get. We're going to define it shortly. And you'll notice I'm putting in quotes because we have two API calls. We have one that takes in a parameter and one that doesn't. And I want to extend this method later on to kind of handle double duty for retrieving those user details. But we're just going to start off simply with this. So let's go ahead and add a new method to our actor here. And it's going to take username as an input parameter. Okay, there is our definition. And now we can actually start working on the communication with the web API. So let's go ahead and define the structure of the sort of create request definition. So we're going to create a shared ref. Shared ref, and it's going to be a AI HTTP request interface. And the mode, we're going to say thread safe for the time being. Request equals HTTP create request. So this is sort of the beginning of our request object. Now let's do a couple of things. If username is actually is empty, then we want to do this. Otherwise, do something else with the username. So in this case, we're going to set the request on process request complete. So this is going to be the callback that gets executed when we actually get a network request response with the payload from our API server. So we're going to bind uObject similar to our overlap component. We're going to say this class get users on get users response. And we don't have this on get users response method yet, but we'll define it shortly. And then we're going to say request set URL. This is going to be the path we're introducing. And I guess, oh yeah, we don't need the parameter here. So this is just going to be a straight up localhost 8080 JMS API users. Pretty straightforward. Now, if we have a username, what we're going to do is we're going to say, request on complete. We're going to bind it to a different method so we can process it independently and apply our own sort of business logic to it. Object this and this class, and we're going to say on get user by username response do something else. And our URL is a little bit different, so let's go ahead and create a parameterized string. And this is going to be host 8080 JMS API user, and then slash s. And here we're going to say username as the input parameter, and that's our other URL. So now we have two methods to worry about. And let's complete the other part of our request. So the verb that we're setting for this request is get, because that's the operation we can only perform with our controllers. We're going to set the header, and the header takes in a header name and a header value. So you can set up multiple, of these guys. So we're going to give it a user agent x real, oops. And that way we know that this is coming directly from the Unreal Engine as a client. You can set these agent definitions to be really kind of whatever you want, but you also want to keep it to some sort of standard that most network operations can understand. And the content type for this request is going to be application JSON. That's what we're communicating with. And then we simply say process request. So this is going to make a call using a get as our verb. It's going to pass in a couple of these header definitions, and then make a little bit of a distinction based on the network signature, or the username rather, to the network signature that is required. On request complete, similar to our other sort of delegates, you can step into and you can dive into the code and kind of see what the structure looks like. But we're not going to go too far into it. What we want to do is we want to steal these parameters for our request complete delegate. So it's going to take these two structs and one boolean. So I'm going back to our get header actor. Excuse me. And I'm going to create a new function. So we're going to call this on get users response, and it's going to take in these three parameters. So request, a response, and a boolean for a successful connection. The other thing we're going to do is copy this and create a reciprocal method for our by username call. Again, it takes in the same parameters as the other one, but we just want to make sure that it's sort of on its own. Okay, let's go ahead and make sure these guys are accessible. Cool. Get user by user response by user name. That's the typo there. Okay. And let's start getting in some definition for these methods. Okay. So let's focus on our users first, and then we'll use that as a basis for some of our other bits of work. And if you recall, our users payload contained a users top level node with a bunch of inner children that represent the user definition. So let's go ahead and create a shared pointer to fJSON object, and it's going to be our JSON object, the thing that contains the value that we parse from the response. And what else do we want to do? we want to say if our response, get the response code equals 200, we only want to do work there, and otherwise trigger an error. Right, so we know that our API only communicates with a 200 response code, so if that is kosher, we know there's some body within the response object for us to process. So if we look at the response, you can get content as a string. So I'm going to grab this this string and just have it available here to us as the response body. That's going to be our JSON payload. And then we're going to make a shared reference to a JSON reader. So the definitions we added here have a bunch of handy JSON parsing components already available within the Unreal Engine for you to work with. So you just need to know sort of who to call when. So I'm calling a JSON reader. I'm just going to call this reader, JSON reader factory. And I don't think we need to give it a type, create, and there's our response body as the input into the reader. Okay. So with our reader available, we can now go ahead and trigger it to populate this JSON object here. To do that, there is a JSON serializer. This guy here. And he has a deserialize method, which takes in the reader and the JSON object as parameters. So if this succeeds, we know we have a populated JSON object. This just returns a Boolean. That's why I'm just shoving it in the if statement directly. And with our JSON object populated, we can now start parsing out components of it. So the way we want to do it is, again, if you recall, we had a top level element called users. So we know it's an array field, right? Because it's going to contain more than one sort of nested JSON object. So we can just simply bring that back with an array of shared pointers of JSON values. So this is our user array. And we're missing a bracket here. Okay. So we can now say if user array is it empty? Is empty. You know what? I'm gonna leave this for now. Yeah, because you know what? We actually don't need to check that because it's always going to be populated with even an empty. So let's do a shared pointer to iterate over these entries of the FJSON values. Okay, so sorry, let's get this name. User object. Or user value rather. And with our user value, you should be able just to say user value as object get string field username, and we can make this a f string username. Okay, so this little bit here should iterate over all of our users. For every user, we should be able to grab a username, and now we can actually do something. So let's go back here and grab a reference to our widget component. So if response widget component, we want to cast to the response widget. Response widget component get widget. And if we have that reference, we want to do a couple of things. So we want to stop loading. Show loading, sorry. So we want to cancel loading. And let's process this stuff on in here actually. So it's all kind of tied together. And now we can say response widget add user username. Okay, and you know what? For the error, let's go response widget add error or show error. And we'll pass in the response, get response code, and some sort of message. Error occurred. So let's go back to the response widget and just put in this method here. Blueprint callable, show error, code, and there's an error message being passed in. So this guy is going to, what is it going to do? He's going to clear the user list before we show the error. And then we're going to create a new text block. New object text block. And I guess we want to change the color of this text. So let's copy this a little bit here. And we're going to say error code. And we can pass in our error code now and our error message. Okay, and lastly, before we set the text, set color and opacity, which takes in a linear color. And I guess we'll just make it red. Okay, so that should show the error if we have an exception with our network call. Okay, so we got the reader. We got our little bit of logic here. And I think we're okay. Now, in the other method, we're basically doing all of the same stuff that is going on here, except we're not iterating over this this array. So a bunch of this logic is basically copy and paste, and then we can refactor it in later tutorials into sort of a more reusable method. So I'm basically taking the guts from our get users into the get user by username And rather than doing this iteration here, I can try to grab the object directly. So rather than using the iterable object, I'm just using the JSON object directly, and I'm looking for the username field, and it should do the same sort of behavior when we actually trigger it. So let me go ahead and recompile, and let's test some of this out in the editor. Before we get too far, I do have one exception during compilation, and it's tied to the usage of the uFunction decorator on our getUser and getUserByUsername methods. So just go ahead and go back to the header file, remove those two, recompile, and you should have no more problems. Okay, let's go back to the editor. Okay, back in the editor, let's see if there's a moment of truth. Let's see if this all works in one shot. So we should see a throbber. Look at that. And there are our usernames. So I've got the server running. It's making the network connection correctly. It's grabbing our details, and then it's updating the widget. And you'll see it tries to refresh it whenever it goes back. And then we only have one little problem, is when our throbber starts, it should be clearing out the list rather than leaving it intact. And it's only doing it at the end. So we'll correct that. But this is actually working pretty good. I'm quite happy with it. Now let's go ahead and turn off the server, and let's see if we can get the error scenario to trigger. Okay, we have the server turned off, and now when we try to make a network connection, we get an exception. It's unable to establish connectivity. It's not even getting a proper error code back. So we got the handling for error situation working correctly. Now let's go ahead and fix up this little spinner issue and introduce a call out to our getUserByUsername method. And the way we're going to do that is we're going to modify our player character to have a name property. If he has that name populated with something, we're going to then pass it into our new actor. That's going to make the network call, bring it back. If he doesn't have that populated, we'll get back our original list. So let's go back to Visual Studio. Okay, so back in Visual Studio, we need to enhance our begin overlap method in our HTTP get actor to be aware of the player. So when the player comes in, we can determine what their name is, and then use that name to pass it into this method. If they don't have it, then obviously we'll skip it. But in order to do that, we need to make this guy aware of our player character. So what we're going to do is, yeah, we can do it down here. So let's do network one live character. So we're going to cast the other actor to our character class. And if we have that character, so we can say f string username, so it's empty. And if we have our character, we can say character get username. Or actually, let's do this. And character username is empty. It's going to be a string. And we want to say username equals, oops, that. Okay, so in the character, we now need to add this get username method. So let's flip back to our character, and let's add a new new property. Edit anywhere, blueprint, read write, category equals HTTP. And it's going to be a username. Now let's create the getter. to go with that. So let's say f-string, add a username, const return username. Okay, so we'll set it at the blueprint level, and then we can use this getter to grab it within our other actor. There we go. Okay, great. So as long as it's not empty, it should get passed in. We should then go into this method. It should pass in the username as part of the parameter, which calls our other response callback, which in turn just grabs the username for a single person. So let's go ahead and recompile and check this out in the editor. One thing I just forgot to do before we move on too far is the clearing of the list when our loading icon was showing. So in our show loading call for the widget, we just want to move the clear list up to the top, so it's always clearing it regardless of the loading state, since our else was just the clear. So let's recompile and go back to the editor. Okay, so within the editor, let's take a look at our third-person character. So under third-person CPP, there's our blueprint. And you should now see under its properties a new username definition here. So that's great. Let's go ahead and test this out to see what it does. And there's our spinner now correctly clearing things. So there's our usual definition. Now let's give it a username of test user or throbber. And we just have that single entry coming back for that user we're looking for. Now, if we change this to be something, I don't know, Bob, a user that we don't actually have in play, we should now trigger the error scenario with a 404. And there it is. So very quickly, we're able to interface with these APIs and sort of massage and process their responses correctly. I don't think there's anything else we want to cover immediately in this tutorial. Let me just double check that we still give back everything when we remove the username. And there we go. We got the test user and all of our other users with the other call. Now, the last thing we can just take a look at is how to grab some of those other properties. So why don't we add the ID as another attribute to our widget. So let's go back to the code and then quickly inject that little bit of logic in. Okay, so going back to our code, let's go back to our HTTP actor. And why don't we go ahead and actually, rather than doing a lot of this logic here and constantly rewriting the addition of our user element, why don't we add an internal method here? Say I want to add user to widget, and let's include the ID and the username. So I'll do a quick refactor. And this can actually be a private method. We don't even need to expose this. But let's add it here. And now we can rip out this little bit of logic right there. Oh, you know what? I guess we don't want to do the reader. Let's leave the reader as is, and let's just grab in this bit here. Oh, and sorry, this is the wrong signature. It should be our pointer to our JSON object. So let's just do t-shirt pointer JSON object, our response widget, this logic. Perfect. Okay, so let's now do a const in 32, user ID. Get integer field. JSON object. Oh, sorry, that's not a wrong parameter. Get integer field, and that's going to be ID. And then our add user on the response widget will also need to be modified. So let's just go and clean this up sort of one thing at a time. That's my t-shirt pointer, JSON object. Okay, and add user to widget. We pass in the JSON object in our get calls, and then the same here. We can just say add user to widget, user value as object. Okay, and we are still reusing a bunch of this code, but we'll leave it in for now and kind of optimize as we go through the tutorial. So I think this is enough for the time being. So let's go ahead and modify our add user to include a user ID. Oops. Username. So let's say there's the ID. Okay, so now we should see the other parameter coming back from our response for both of our network calls. So let's recompile, go back to the editor, and finish this lesson off. And before I go too far, I did have one compilation issue here on the user ID. The response widget was missing the parameter, and I also had a typo on the blueprint callable, which you might have caught if you were watching it. Let's just recompile and test this out in the editor. Okay, so in the editor, let's go ahead and see if our new parameters are showing. Perfect. So we have the IDs coming back along with the username. Now, if we go back to our character and introduce, actually, let's do JMS user. So that should come back with an ID of 1. 1 or 2? By the way, it should go back with 1 ID for the username. 2. Okay. So it's working correctly. If we change to test user, it should come back with 1 accordingly. Okay, so this is working great. Now, before we shut this all down, let me just pull up the server and the game together, and we can kind of see what's happening. Okay, so now with everything running sort of side by side, let me show you here on the left what's going on with our console when we actually play our game. So when I step in here, you'll see there's our network request. We're getting the 2 headers that we're including, application JSON, as well as the agent. So we can now be a little bit more clever in some of our processing and start including additional header elements for things like security, various tokens, any other sort of bits of information that you may require. But there we go. This is the sort of initial steps in some of our network tutorials. We're going to look at posts and deletes and ways of manipulating this data on the left-hand side on our server through our game content, eventually leading into things like a UI where you can actually sign up and do all of that sort of kind of inbound processing. Maybe we'll even create a browser, who knows. But it's a lot of stuff to cover. Feel free to ask questions in the comments area if you have any concerns. Thank you to the Patreon subscribers. It's always very much appreciated. And again, thank you for checking out my content, and hope to see you guys next time.